All right, class, welcome back. Today we're looking at the Pythagorean theorem one more time. Remember that you will not be required to turn in any of these worksheets for the remainder of the school year. But I highly suggest that you start taking notes in a notebook so that you can have something to refer to when you are doing the homework assignments that will be done through quizzes and the tests that will be done through quizzes as well. So make sure that you take good notes so that you don't have to come back and look at the videos while you're doing the actual homework assignments. All right, so here we go. As we take a look at day 2 of the Pythagorean theorem, what we're going to take a look at today, again, is how we are dealing with right triangles. Now, the activity for today is going to be to determine whether or not something is a right triangle. So it states here that if A and B are the measures of the shorter sides of a triangle, yesterday we called those shorter sides the legs, okay? And C is the measure of the longest side. Yesterday we called that the hypotenuse, okay? Then the triangle is a right triangle. So it says if the measure of the two shorter sides is um, if they are equal, see here, so if c squared is equal to a squared plus b squared, then the triangle is a right triangle. So the thing that we're going to be checking for is that they are equal, that the hypotenuse squared is equal to the two legs squared when added. So the sum of the two shorter sides. Okay. Now, you'll notice that in the examples, they are putting this as a question mark here because that's what we're doing today. We are checking to see whether or not these are equal. So you'll see that question mark is written right there and right there again. And so basically what we're trying to check for is, are they equal? Because if they are not equal, then this will not be a right triangle. So you'll see here that if they are not equal, then it cannot form a right triangle. All right, so that's the main concept for today's lesson. Determining whether or not it is the sides of a right triangle. So we're going to determine if we have a right triangle. Okay, so let's take a closer look. It says here, since the greatest measure is 14, we have to let C be equal to 14 because that's the biggest number. So if it's the biggest number, well, obviously it's going to be your hypotenuse because that's the longest side. Then your two other sides are going to be the legs. So when we substitute it into the formula, c squared equals a squared plus b squared, you'll see that the 14 squared gave us 196 right there. Then the a squared, which was 10 squared is 100, and 12 squared was 144. When we added those two together, we got 244. And obviously, 196 does not equal. That's why we use the not equal symbol. That's what that is, an equal sign with a slash right through it. That means it's not equal, okay? So if it's not equal, then what we are learning from today's lesson is that it will not or cannot form a right triangle. Okay, so now let's take a look at another example, okay? Let's take a look at example B up here. Let me move this up. And then it says, as we take a look at the numbers 7, 24, and 25, you'll notice that 25 is the biggest number. Therefore, that has to be your hypotenuse. So they've placed the 25 right there. Okay. Then you take the 7, which is the shorter one. That's going to be one of the legs. And the 24 is the next sized one. So that will be your other leg. So you have 7 squared plus 24 squared. Okay. Now, right around now, some of you guys are wondering, well, does it matter which is A and which is B? It doesn't really matter. But I like to always get into the habit of making A the smallest one, B the middle, and C the biggest. But in reality, the A and B doesn't matter, okay? As long as the C is the biggest number. All right, so when we substitute, we get the value of 625 for the 25 squared. 7 squared was 49. 24 squared was 576. And then when you added them all together, you get that 625 is in fact equal to 625. Therefore, since the c squared is equal to the a squared plus b squared, we do form a right triangle. So we do, okay? They do give us a right triangle. So that, in essence, is what we are checking for today. We are checking that c squared is equal to the a squared to b squared. If it's equal, then you say that you form a right triangle. And if it does not equal one, then you say that it cannot form a right triangle. So if you look at the instructions for the exercises, it says determine whether each set of measurements can be sides of a right triangle. So that's where you're going to do the calculations as we've seen in these examples right over here. Okay? Same calculations. Then it says determine whether they form a Pythagorean triple. Now, a Pythagorean triple is something that we're just now seeing. Okay? Now, a Pythagorean triple is basically three numbers that will give you a right triangle. The most classic one, as I explained yesterday, was 3, 4, 5. Now imagine that I multiplied the 3, 4, 5 by 2. Well, I would get 6, 8, 10. That means 3 times 2, 6, 4 times 2, 8, 5 times 2, 10. This one is a verified Pythagorean triple. 3, 4, 5, we saw yesterday, is a Pythagorean triple. So basically, if I was to take just about any number and multiply it by the 3, 4, 5, I would get a Pythagorean triple. For example, if I multiplied by 3, I would get 9, 12, and 15. Another Pythagorean triple. Now, you guys could go ahead and check it, do the math on it, but I guarantee you that 9, 12, and 15 are also a Pythagorean triple. And there's a whole bunch of Pythagorean triples. Okay, so you're going to come across them, but what we're checking for today is, do these give us a Pythagorean triple? Basically, does the c squared equal the a squared plus b squared? All right, so let's take a look at example or exercise number 1. You have 50. That's your biggest number. That's your c. And the 14, that's the smallest. And then the 48, and you square that. Okay, now when you first take a look at it, you think, well, there's no way that's going to work out, but I ask you to just check the math. Okay, do the math. Here we go. So when we get the 50 squared, that's 2,500. 14 squared is 196, and 48 squared is 2,304. When I add the 2,304 and the 196, I get 2,500. Therefore, this is a Pythagorean triple because my c squared is equal to my a squared plus b squared. Okay? And you do this over and over again with all of these exercises. Now, if we skip down to number 13, you'll see that 300 is my largest number. So that's going to be my C. The 100 and the 200, A and B. And then when I go ahead and do the math, I can see right away that there's no way that this will be a Pythagorean triple. 90,000 is not going to equal 50,000. So this will not be a Pythagorean triple. So you can do this with very large numbers as well. Okay, let me show you a few more examples. If we go back up to number 6, you take a look at the 4, the 8, and the 4 square root of 5. And you may be wondering, well, which number is bigger? Well, take the 4 square root of 5, put it in your calculator, and see if it's actually bigger than 8. I did, and I got 8.9 something. Okay, so that's how I know for a fact that the 4 square root of 5 is going to be my C value. So then once I go ahead and assign that to my formula, I can go ahead and get my values here. When I square the 4 square root of 5 on my calculator, I get 80. Okay, and then I check it. Is 80 equal to 16 plus 64? Now when I add 16 and 64, I do in fact get an 80. So this is going to be a Pythagorean triple. It will be. Okay, and again, keep trying, keep trying. Like number 8, square root of 20, we need to know, is that bigger than 4? So you put that in your calculator and you go ahead and try that. Okay, I hope that this video helps you. You can always go back and replay it, pause it, take notes. But basically what we're doing today is just substituting values into the formula as described above. C squared equals a squared plus b squared. And we're checking to see whether or not we have a Pythagorean triple, which is basically going to tell us if it is in fact a right triangle. All right, that is today's lesson. I'll see you guys on Wednesday. Have a great day, guys.